Okay, we're going to look at some basic statistics as outlined in our Chapter 12 sections. I couldn't find any videos online that went over what I wanted them to go over without going over additional things or looking at things exactly how we do them, so I'm just going to make our own video. So in case you were absent today, or just want to look back through to refresh during the week, we're going to go through kind of the PowerPoint again, look at some things ourselves here. So we looked at some basic statistics. We're starting off with measures of central tendency. Those are pieces of data that measure sort of what typically happens in a set of data. So for example, we have mean, median, mode, right? They kind of measure the centers of the data. We try to get a look at what typically happens. So the first one is the mean, and we should be pretty familiar with mean. It's the same thing as average. This is its little symbol. If we see in a formula later, they're going to want us to find the mean, and they're going to tell us that by using this symbol, an X with a bar over it. And the mean is just used by adding up all the items in your set of data and dividing by how many items you have. The median is the middle number. So you would want to arrange all your numbers in order from least to greatest. That's the most important part that people forget with median. It's the very middle number. So line up from smallest to largest, and then kind of find the number in the very middle, kind of check off on the ends until you get to the middle. If you end up getting to the middle and there's no number right smack dab in the middle, because maybe you have an even set of numbers, so there's no middle number, then you would just take the two numbers that are there and average them. So for example, if you had the numbers 1, 2, 3, and 4, and you wanted to find the median, obviously 1, 4, 2, 3, there's no number directly in the middle because we have an even number of numbers, so we would average 2 and 3, or find the mean of 2 and 3, okay? And then the mode means the most, basically. It's the value that occurs most often in your set of data. Now with mode, that's one where we could have one, we could have more than one, we could have none. Right? You're always going to have a mean and a median, but with mode, for example, here we don't have a mode. They all occur at the same amount of times. There's no number that occurs more than once. But say it was 1, 2, 2, 4, then our mode would be 2. If our data was 1, 2, 2, 3, 3, 4, then our modes would be 2 and 3 because they occur the most amount of times, and both of them do. So at this point, there's going to be a in your packet that you could print off Blackboard. The next slide is one for you to practice. So pause now, because I'm going to turn it, and when I turn it, the answer's there. So pause and do it. All right. You're paused. You're paused. We're coming back. That's what you should have. All right, we're looking at this set of data, weekly temperatures. Our mean is 84.6. We added them all up, divided by 7. Median, I lined them all up in a row. Our middle number ended up being 86. And the mode is 82 because it occurs the most amount of times. We have two 82s in that set of data. Okay, so that's mean, median, and mode. Right? Those numbers are used usually to represent, kind of be representative of the data as a whole. What typically happened? What could I expect? Okay. Then we're looking at a couple measures of dispersion. One is the range. Dispersion, if you think of the word dispersed, like spread out, it's a measure of spread, basically. And the range is just basically saying, okay, what is the range of my data? How large is the spread? You would just do the greatest value in your set minus the least value in your set. So largest number minus the smallest number. So for example, in our temperature data, our largest number was 90, our smallest number was 75, so our range is 15. There's a 15-degree range in our data, right? From smallest to largest, there's a 15-degree difference, okay, which is actually kind of big for weekly temperatures. What are the odds you're going to have a 75-degree day and a 90 day in the same week, given, where we live with the seasons and everything, but maybe weather was fickle that week. So, excuse me. So we could expect in, something like that to have a small range, whereas if we were looking at test scores, for example, the range might be much larger because you could have someone who did really poorly versus someone who did really well, and your data would be more spread out. The larger your range, the more spread out your data is. Right. And this is just a page I put in here to note. I have, 5 quizzes and 2 students, and it shows their scores on each of the quizzes, right? And I just want to show you how, why we need so many, in statistics, so many different measures of data, because sometimes data can be misleading on its own. All right, so I just wanted to get across the point that just looking at one piece of information can be misleading. It might not give us the whole picture. That's why we have so many different ways to look at it. And I said, for example, if we look at the range, right, Max's range is 10, Molly's range is 22. So just looking at that real quick, it looks like, he was probably more consistent because there's not this big range between his lowest score and his highest score. So it looks like he was a little bit more consistent and Molly wasn't. She looks like she might have been a little bit more all over the place because it was 22 points difference between her lowest and highest test. Looking at the mean, it looks like, their performance might have been about the same. If we're looking at mean, well, if their average is 23, so that's about how they did on their tests, on their quizzes out of 30 points. All right, but if we actually look at the data, right, consistency-wise, we got 28, we're down 6 points, we're down another, we're up 5, we're down, 8. He's a little bit all over the place with his scores, whereas Molly actually does look more consistent overall. This one guy threw her range all off, right? Other than that, she was 27, 27, 28, 27. She was pretty consistent with her scores. So that one guy kind of threw her all off. So if we just looked at the range, it might not really give us a good picture of who was more consistent as far as their scores are concerned. Also, it looks like, for the most part, her scores were the same or higher than Max's, even though the average would have you believe that they performed about the same. All right, so that's what I'm talking about. We might want to look at a few different pieces of information before, we make a judgment about something, and just kind of looking at what mean, median, and range could tell you about a set of data. Okay? Another measure of spread or dispersion is the standard deviation. The standard deviation, if you think of the standard as like the mean, and deviation is how far you're deviating from something or how far you are from something. All right, standard deviation is based on how far each piece of data deviated from the mean. Okay, and here's kind of an analogy sort of to say what standard deviation represents. If you have 10 people and you add their ages together, divide by 10, you get the average. So we're getting the average age of 10 people. The average then becomes the standard, right? That age kind of represents our group as a whole. Then you compare each person's age with that standard, and the difference between the two is the deviation. So let's say we did that and the average age we had in our class was 25. Let's say you are 26. You deviated 1 year from the average. You were one away from the standard that we set. So that would be your deviation. Someone else who was 20 years old deviated 5 years away from the standard, okay? So the standard deviation of an entire set of data is the typical difference in age from the average age of the group. So the typical difference, okay? So standard deviation, let's say if we said was 2 years, then that would mean that, if our average was 25, then our average age was 25, and most people were within 2 years of that. So maybe between 23 and 27. Most people would fall in that range. We'd say, average is 23, give or take 2 years. That's kind of how I think of standard deviation, give or take. Right? Most of the people fell within 2 years of that average. Okay, that's what standard deviation is. Right? Here's the fun part. How to find standard deviation, okay? There's a whole process. Fortunately, we got it kind of spelled out right here. First, you're going to find the mean of your numbers. Then you're going to find the deviations from the mean, meaning take each data value you have and subtract the mean from it so you can see how far away it is from that mean. You're finding those deviations. Then you're going to square each deviation. Once you square all those deviations, you're going to add them up. Once you add them up, you're going to divide by n minus 1, the number of data items minus 1, okay? And then once you have that, you're going to take the square root of it, and that's your standard deviation. Now, depending on what you look at, I've seen some stuff online. There's some that'll give you an equation where this is just divide by the number of items you have, not the number minus 1. Our book does n minus 1, and there's arguments for that, for using that as opposed to n. So if you look online and you find something different where they just divide it by n, meaning the number of items in your data set, don't get confused. We're using the formula where you're going to divide it by n minus 1. Okay? So, excuse me. Here's an example all laid out for you. Okay? Wants us to find the standard deviation of this set of data. So, first, I calculate the mean, add them all up, divide by 8. Our mean is 23. Okay? Find the deviations from the mean. So, I took each piece of data I had and subtracted that mean from it. 7 minus 23 was negative 16. So, because 7 is 16 below the average, 9 is 14 below the average, 18 is 5 below the average, so on and so forth. Once you get numbers above the average, right, this is 4 above, 6 above, 9 above, 17 above. So we're in positives. So that's what we mean by deviation. You can just subtract, figure out how far away they are from the average. Then we square them. All right, I squared them all. Negative 16 times negative 16 is 256, so on and so forth. Took all those guys, add them up, got 900. Then I divided 900 by n minus 1, meaning the number of data items minus 1. I had 8 data items, so I'm doing 900 divided by 7, which is 128.57. And then I take the square root of that and got 11.3. Phew, a lot of work. So, excuse me, at 11.3, that's the standard deviation. So we have a mean of 23, give or take 11, right? Mean of 23, but this looks like we're going to have a wide spread of data here if most people are within 11.3. I'm saying people, I don't know what this data is representing, but if we're looking at that, if most of the numbers in the set are within 11 either way of 23. Okay? So on the next slide, there's one for you to try. I'm going to pick this up in the next video because I'm afraid my video is going to get too long and it's going to tell me I can't upload it. So you're going to pause, you're going to do the next slide, and then we'll be back.